And now we will listen to Matthias Klein, how to use open source software to have near production development and testing environments. Enjoy.
Okay, welcome. Yes, the question is, why do we use or do we need near production development environments? And the reason is to know what will happen in production later when we develop our software. First, I want to introduce myself. I'm a system administrator in browser gaming companies since 6 years. And I'm responsible for the internal systems at InnoGames since 2 years, and I'm building the infrastructure there. And InnoGames develops browser games. We have 150 million users at the moment. We are located in Hamburg. The infrastructure we are talking about now are around 8,000 servers. Of 90% of them are virtual machines. We are using Xen at the moment. We are using Debian on almost all servers. Then we use Puppet. We use Jenkins for package building, the normal Debian tools, dpkg-deb. We use Isinga for monitoring. We have an admin tool written by one of my colleagues, which is our inventory system. And it is important to have this because you want to push additional information to Puppet, like Puppet environments, and I'm talking about this later. And we use our own package server. For this, we used apt-mirror, but we rewrote it or extended it to have better control over the things that are happening to our repositories. And you may know the situation. Your developers develop new fancy code. They test on their machines. Maybe they test on testing environments. They deploy to production, and this happens. The main reason why this may occur, or what we experienced, is that we have different software versions on development machines, testing machines, production servers. It may happen that developers need some new modules and simply install them on their machines, and when the software goes to production, the module is missing. That's it. Then we have had some deployment issues, so that there were build steps involved in the deployment, such as running Composer on the target machine, which is not a good idea if the target machine can't reach the repository for any reason. Or there are configuration differences in development, testing, staging, production environments, such as missing rewrite rules and so on. All this may happen. And new system, a system you can build will go this way. Nothing happens, everything is fine. And we changed many things in our development and deployment cycles. So the developers have their vagrant machines locally, and the vagrant machines are provisioned by the same Puppet files as the production servers. This is at the moment work in progress, but I hope to have this finished soon. We use Jenkins simply as a job starter. In the previous environment, Jenkins tested the software on the Jenkins machine. Then we ran into problems like, oh, this software needs PHP 5.4, this one needs 5.6, and so on. And that's not a good situation. So Jenkins simply connects to a virtual machine and runs the job there and gives you the output. Then Jenkins is used to build the Debian packages when we need them, and then it pushes them to an internal repository server. Then we can deploy from there. And the package is pushed to the testing system, which then means if we deploy into production, we deploy a package what we already tested. Puppet is very, very important. You will know that it's a configuration management system. You also could use Chef or CF Engine, what you like. It should work with different systems. And we make use of Puppet environments, which means you can have multiple, or it's like multiple Puppet master servers, but you have it on one server, and you define which machine is in which environment, which leads to the situation that you only have to define a Puppet manifest once, or you have to define your configuration files once as template, and then you can inject variables for use in your different environments. Then we are using external nodes, which is simply a script that returns the classes which have to be applied to the Puppet, and also some variables you may need, like IP addresses or which environment the host is in. And we use hiera, which can define additional variables to use in different environments. You have one possibility, for example, if we have here a production and a testing server, you can write your nginx config, set the server name, write 2 config files, then you have the Puppet manifest, and there you say, okay, if the name is server 1, then it gets 1 config, then if we have the other server, it gets the other config. This is not very nice because except for the server names, the config may be equal. So if you change one parameter in one config, you have to change it in the other one too. And this is very inconvenient for you. So you should use hiera. Here we see an example of a line in hiera. It's a JSON file where you can put in your different values. And here we see 2 different environments. We have one manifest. There we pass the variable server name. Then we use the file nginx config as a template. It's a Ruby file, and we have one config file where we use this variable. And if you do this for the different things you need, then you can go on with one single definition. You can also pass proxy hosts and so on. You define it in here. The next important thing is the package management. As I said, we are using Debian, and if you use the upstream repositories, you have more or less the problem that if your developers are allowed to install software on the servers, that they may install wrong software packages you don't know about. Then you run into the problem you can't upgrade them. So we decided to build our own repository server. This gives us control over the packages which are available on the machines in the end. It gives us control over the versions of the software. We can use latest in Puppet for packages. So if we decide to update libSSL, then we are sure that the libSSL is the most recent version on all servers. Then you can make testing easier with dedicated repositories. So you will have one repository server which holds the repository for your project, and then you have simply an additional testing repository, and then you can tell the machines or special machines you want to test, you can tell them, okay, please use the testing repository, you check everything, and when it's fine, then you can say, okay, I copy testing to production. And everything should run fine. You can never say, but in most cases it's okay. And the next thing is, you can deploy your application via Debian apt. You need this repository if you want to deploy your software via packages. You should have this server, because you could use dpkg and simply put the packet on every server and then install it there, but believe me, it will get a mess of packages in the end. What you need to build your own packet server is, of course, a machine with a reasonable amount of disk space. And then you can use apt-mirror to mirror repositories to your own server. Then you would select the packages you need for your project, put them in your repository. We use hard links because of the disk space. At the moment, we have around 80 to 100 repositories on our servers, so it makes sense to have hard links. You have to take care of the dependencies, of course. And in the end, if you put all files you need in your directory, you can use FTP archive to generate your packages files, to generate signatures. Then you have to enable HTTP or FTP, that your servers can fetch the packages. And you can do it all by hand. You can write your own scripts, but we have already done this. We have some scripts to handle the repositories. They are not available at the moment because they need some polishing, but I think within a month we can provide them. So you can have a basic repository management on your own. You can extend them. They are written in Python. They use Python apt. It's a very nice way to manage your repositories. But you have to be careful. If you use the Puppet latest functionality, then you should not allow other sources than the ones you defined. You can make sure that this is done by Puppet itself. You can have Nagios or Isinger checks for it that warn you something may be wrong. You should also check that every package which is installed on your machine, that you have it in your repository. Else you might miss updates or important security updates. And we experienced this situation when we had like 60 packages not in the repository because they came from the installation image and nobody knew about some libraries. And you may find packages you don't want on your production servers, like a compiler. Then, of course, you should check if the packages on your machine are the same version as in your repositories. If you put every package in Puppet to latest, it's okay, then there should be no package in a different version, but maybe one package couldn't be installed correctly, or you don't want a package to be latest like your database, which you want to install by hand to check if everything is all right. Then, of course, you should check your repositories if they are up to date with the upstream repositories or the official repositories, because you think everything is fine, but you never put in new versions of important libraries or important packages. And then you might have to explain to your developers why they can't install most of the packages because they aren't in a repository. It depends on the situation you have. In our companies, the developers are allowed to install packages on the servers, and this is the workaround at the moment to know what happens on the machines. The next thing is the role of the Jenkins server, which is, as I said, a simple job starter. You can easily create VMs if you have your Puppet manifests right. If you define everything, then you tell simply as an environment Jenkins, and it builds your server with the server name you need. We use Xen VMs because I tested it with Vagrant on a hardware machine, and as long as you have one project in the Jenkins, everything is fine. Or you want to start only one machine. But if you start multiple different instances of Vagrant machines, you run into problem, most probably because of VirtualBox, which we are using or which we used in this case. So, there's a workaround to start the machines one after the other by implementing log files into Jenkins, which simply manage when a machine may start or stop. But it's a very, very ugly way. The next thing is that the provisioning of a machine takes very, very long, up to 10 minutes we experienced. And that's not very good if you want to make quick tests. You can suspend your machines, but then you have the problem that you are not sure if your Puppet manifests still are able to fire up this machine from zero. I've often experienced manifests when we extended existing manifests and nobody tested if I start from scratch, does it work? So we implemented tests for this, but this means if you change something in your Puppet config, then you have to rebuild all machines which are based on that to check if it works, to apply the changes. And it takes a long time. And we had overall performance issues, especially with IOPS, and we had 1/10 of the performance compared to Xen. And for testing, this is not so nice for the developers. So they complained, yes, this test is using 8 minutes on your on our official Jenkins, if I do this test on my machine, it needs 1 minute. So that's the reason why we switched to Xen again. How it works now is that you need a build trigger in Jenkins for the Debian packages. We use a GitLab server for our repositories. There you can define events and hooks. Then when someone tags a version in GitLab, then Jenkins gets this information. Jenkins builds, or Jenkins please build the package. So then Jenkins once does the whole composer stuff, puts everything to the path you want to have on the server in the end. Then the Debian folders are created. We have a skeleton for it, so simply data is copied. We fill out some information like version. Then you can use scripts for handling your package, what should happen before, after installation, before, after deletion, before, after upgrade. Maybe your application contains a daemon, you want to stop the daemon, then upgrade it, start it again. That you can put into the files. And to build, it's a very, very easy command, dpkg-deb -b, the directory where our files reside, and then where I want to have the package. Then the next step is to push or pull, depends on how you want to do it. The package has to get somehow to your repository server. And then there you generate the package files. Everything's fine. So in this moment, we have our package. The package is on our testing system. And then we decide, okay, it's a nice package, we want to use it. How to get this package into your production? It's very easy if you go via SSH everywhere. You could also put it into Puppet as latest, but then you have the problem that you didn't test it on your staging system because you uploaded it to your repository server. So you have to decide, do I want to have the package on the repository server automatically and tell the system, okay, install now? Or I decide to have the package on the repository later and let Puppet manage the installation. So you have to, or another thing might be if you say, okay, when our tests are done, I'm sure that the package will work and I push it to production. You can do this also, but I think it's very dangerous. Okay, now we have the package on the server, everything is fine, and we come to the role of vagrant. Yes, you can configure vagrant to use the Puppet server provisioner, so not using shell, or additionally using shell, you can do this if you like. You should set up an environment for vagrant in your Puppet. We decided to have a dedicated server for this to not conflict with production because the developers are writing the Puppet scripts there or doing maintenance on the Puppet scripts. And maybe you don't want to have these changes immediately in your production system. So you need to teach your developers how they have to handle the whole Puppet stuff, what they have to do to achieve certain things. A nice thing is to have it in a version control system, Git, SVN, as you wish. And you should check these definitions against the ones you have in your production environment, because you might want to have these changes too for the new software version. Additionally, there are some classes which are only used for the vagrant box, like xdebug or something like that. Therefore, you could add an additional class which you don't check, of course. But it is a good idea to have this class also in the repository for your production, but not in use, because by accident someone could put definitions in there you might need in your production later when the package goes online. So that's it for the moment. Thank you for listening, and are there any questions?
How large is your entire infrastructure around?
What do you mean?
For the developers, how many developers work and how many servers or infrastructure test systems you're hosting?
We have test servers around 100, developers 150, and then productions are around 6,500. The question is if we have a way to review code before it goes to production. Yes, more or less. We use Puppet lint, which is a Git commit hook, and if it goes through, then it goes through. Additionally, we have environments for testing. So if you change something in Puppet, you should use the testing environment, which is simply switching to another branch. Then you can change everything you need. You check it in, then you define one machine or multiple machines to use this testing environment, and this works fine if you follow this workflow.
When you deploy new software to the production systems, do you it all on the same time, or do you it in batches, or how do you make that there is no interruption of the production system?
The question is how we deploy software if regarding interruptions in the production system. It depends. We have systems which are allowed to have an interruption in the service, and there it's easy. You deploy and you have a downtime of 5 seconds. Most players even don't notice that. But in the back-end services where you have payments and so on, there we have a load balancing, which means we take one or a part of the service out of the load balancing. We do the update there, check if everything is all right, then we switch, then the new version is online, we update the rest and switch them online again.
Also with Puppet? Or?
No, this is done, you can do it by hand if everything fails, but we have a update daemon, So this update daemon listens if there's a request for the update, then it takes care of switching off the load balancing, applying the packages, and doing all this stuff.
Any more questions? We have still time.
You mentioned you all using all apt-mirror.
Yes. The thing is, if you use
Can you repeat the question, please?
Oh, the question was, we are using an own apt-mirror script. The thing with the original apt-mirror is that it really mirrors the repository you are fetching from. So, which means it throws out old versions, for example. So you have only the latest version. But in our environment, we want to have a certain amount of older versions to have the possibility to switch back. And we changed this behavior to simply configure how many old versions we want to have for certain repositories. Then the handling of the Debian repositories is sometimes ugly. So we said, okay, so if they switch to another repository name, for example, if they switch to archive, it would also download this repository and you have it twice, an old version, a new version. And to work around these issues, we use this tool.
Is it available on GitHub?
I think in a month, in around a month, you can write to my email address, and then I will give you the link. Yeah.
So when do the developers actually test the new application? Do they test it in a vagrant box, which gets built afterwards, or when do they expect to do this?
The question is, when do the developers test the application? The first tests are done in the vagrant box. First small tests, we develop, look how the page looks, does everything work, okay. Then it gets checked in. Then a Jenkins job runs with unit tests and so on. When they decide, okay, all unit tests are okay, all tests I have done on my vagrant box are okay, then they tag the version. Then this causes a build, except they use it in RC. You can build it. So if they say, okay, we want to have a release candidate now, then the workflow is that the release candidate won't be published to the production repository, but will be available on the staging server, where you can test again, and where the QA is also testing. And when they say everything's fine, okay, then it gets the final version and goes live.
Okay, just for following up, so how do you handle the case and say the operations team is changing something in Puppet? Will that be automatically pulled to the vagrant box, where they hook up to the Puppet master, or they have really considering that?
It will not be pulled to the vagrant box by default, but it will be on the Jenkins and on the staging systems. But if you wish, you can implement it to be pulled to the vagrant box by simply adding a cron that runs Puppet every 10 minutes or so.
I'm just asking, because like sometimes the developer works on a testing machine.
Yeah.
He wants to try out some, let's say, property changes. Just like change the property, see if it works. If it doesn't work, then go back to it. And so, if you want to have Puppet to enforce the state of the machine, to see like, okay, the guy with the test box with the latest changes from Puppet already in place.
Yes, it's a bit difficult. As I said, you can force the vagrant box to be like the real system. But in the case you want to test, you don't want Puppet to override your changes, which you are testing at the moment. So, of course, we don't do this. The developer then has to make sure that the changes which he does to the configuration is put to Puppet. And additionally, of course, it should fail when you test later. So you have to get used to it.
One last thing. How do you deal with infrastructure-related information or environment information? Because the developer probably won't know the IP address of the database cluster in production. So how have you solved this problem? Or is that a two-part process where the part is done by the developer for the other part is defined by a version?
Okay, the question is how we deal with infrastructure and the application. Is that right? Or for example, has the developer to know the IP of the database? Usually he knows. But mostly we are using a DNS name which never changes. So if he needs database access, he asks for connection data. And yes, then he will get the name of the host, he will get the user, the password. And this is also managed in a repository. So yes, the developers could look it up if they want, if they need. System administration can change it if they need. And it's part of the configuration of the application, which is fetched during the installation of the package.
Thank you.
All right, any more questions? Okay, guess not. Then thank you for the presentation.